Hello friends, today we are going to discuss about binomial distribution. We know that if we have success and failure, then we go through Bernoulli distribution. But some of Bernoulli distribution is converted into binomial distribution. So today we are going to discuss about binomial distribution. We will see its mean, variance, MGF, some real life application in this video. So first of all, let's see the definition of binomial distribution with its PMF, probability mass function. A discrete random variable x taking values 0, 1 to up to n is said to follow a binomial distribution with parameter n and p if its PMF, this probability mass function, is given by P of capital X is equals to small x. We can also write it as P of x is equals to NCX P raised to x Q raised to n minus x. Here NCX means n combination of x, and the range of x is 0, 1 to up to n. Discrete distribution, hence its range is discrete. Range of p is 0 to 1, q is equal to 1 minus p, and we know that total of p plus q is equals to 1, 0 otherwise. Let's say in a notation form how to write binomial. X follows b in bracket n comma p is general notation for binomial distribution. Here parameters are n and p, so we have two parameters for binomial distribution. Let's see some real life applications which we are seeing in a daily life. First one is number of defective atoms in a lot of n atoms produced by a machine. Number of male birth out of n birth in hospital. Another is number of correct answer in a multiple choice test. Number of rainy days in a month. Number of seeds germinated in a row of n planted seeds. These are some real life applications of binomial distribution. Let's see its mean. First of all, definition of mean, how to define the mean. We know that mu r dash means rth raw moment, and r is equals to 1 means first raw moment is our mean. So mu1 dash is equals to mean is equals to summation x into probability of x, p of x, and x goes from 0 to n. Here we take summation because we dealing with discrete distribution. If we are dealing with continuous, then we can go through integration. Okay, let's derive the mean. We have PMF, probability mass function, NCX P raised to x Q raised to n minus x. Let's substitute summation x into P of x. So x into, we can write NCX as n factorial upon x factorial into n minus x factorial. Just we write this, other P of x Q raised to n minus x is as it is, and we can just split the term and some terms get cancelled, and n factorial as it is, we can write x factorial as x into x minus 1 factorial. Okay, so nothing changed in the this function. So x and x, this x, numerator and denominator x get cancelled, so remain is x minus 1 factorial. And range also change, because if we take x is equals to 0, it's no meaning. So our range is from 1 to n, p raised to x q raised to n minus x. After that we have taken n minus p कॉमन, यहाँ से हमने n माइनस पी कॉमन निकाल लिया. कैसे? तो n फैक्टोरियल को हम n इंटू n माइनस 1 फैक्टोरियल लिख सकते हैं. जैसे कि प्रीवियस केस में हमने x फैक्टोरियल को x इंटू एक्स माइनस 1 फैक्टोरियल लिखा था, वैसे ही यहाँ पर n फैक्टोरियल को n इंटू n माइनस 1 फैक्टोरियल लिखा है. तो np गेट कॉमन. So if we have taken p common, so p raised to x become p raised to x minus 1. Okay, so nothing changed in the function. So np is as it is, summation. This we can write in the term of combination, like as our PMF, n minus 1 factorial upon x minus 1 factorial, n minus 1 minus, here factorial is outside, typing mistake is there. So this one and this one get cancelled, so nothing change will happen here. So n minus x factorial and n minus 1 minus in bracket x minus 1, this factorial will be outside, so just typing mistake, please correct it. So no change will be here, so the term remain as it is, just we take some arrangement. So p raised to x minus 1, q raised to n minus x is here, we write it here. This is our, this like it as a binomial PMF. Okay, so NC n minus 1 c x minus 1 p raised to x minus 1 q raised to n minus 1 minus x minus 1, we can write it as p plus q bracket raised to n minus 1. How? We know the binomial expansion. What is binomial expansion or binomial formula? A plus b bracket raised to n is equals to summation nck a raised to n minus k b raised to k. So here instead of k, our random variable is x. Like that we can write p plus q bracket raised to n minus 1, and we know that p plus q is always 1, so 1 raised to something is 1, so np, so mean is np. Okay, this is our mean of binomial distribution. Let's see the variance. First of all, we see how to define variance. Variance is equals to mu2. Mu2 means second central moment. Mu2 is equals to mu2 dash minus mu1 dash square. Mu2 dash means second central moment, sorry, second raw moment, minus mu1 dash is first central moment. Central moment means, sorry, first raw moment. Raw moment means mean. So mu2 dash minus mean square. Okay, so first we will find mu2 dash, and we know the mean. mu1 dash is already known, so we just find the mu2 dash. Mu2 dash means expectation of x square. So we can do arrangement here. एक्सपेक्टेशन ऑफ एक्स स्क्वायर को हम कैसे लिख सकते हैं? एक्सपेक्टेशन ऑफ एक्स इंटू एक्स माइनस 1 प्लस एक्सपेक्टेशन ऑफ एक्स. If you multiply this x inside, what you will get? Expectation of x square minus expectation of x plus expectation of x. So expectation of x, expectation of x will cancel. So expectation of x square remain as it is. Nothing will change. We will find expectation of x into x minus 1. How to find? Let's say summation x into x minus 1 p of x. P of x means ncx p raised to x q raised to n minus 1, just like as our expectation. So x into x minus 1 is as it is. This combination term, write it as n factorial x factorial n minus x factorial p raised to x q raised to n minus x as it is. N into n minus 1 p square. This term get common. So this n factorial we can write it as n into n minus 1 n minus 2 factorial. So this term get common. Here also x factorial we can write it as x into x minus 1 x minus 2 factorial. So this x into x minus 1 numerator denominator get cancelled, so remain is x minus 2 factorial. This is intermediate term, you can easily calculate this. So we can again define this as n minus 2 combination x minus 2 p raised to x minus 2 q raised to n minus 2 minus x minus 2. If you multiply this minus sign inside, so 2 get cancelled, n minus x, so nothing change will happen here. N into n minus 1 p square is as it is. This is again as a binomial expansion, so we can write as a binomial formula or expansion, whatever you can say. So p plus q bracket raised to n minus 1. We know that p plus q is 1. So we get expectation of x into x minus 1 is n into n minus 1 into p square. So our mu2 dash is n into n minus 1 into p square प्लस np. यहाँ पर हमने अभी तक सिर्फ mu2 डैश फाइंड किया है, मतलब सेकंड सेंट्रल मोमेंट रॉ मोमेंट हमने फाइंड किया है. वेरिएंस देखेंगे, वेरिएंस ऑफ x इज इक्वल टू mu2 डैश, सेकंड सेंट्रल मोमेंट इज इक्वल्स टू n into n minus 1 p square plus np. Just we find it here, mu2 dash. Okay, minus mean square means n square p square. So if you multiply this n and p inside, n into n square into p square minus np square plus np minus n square p square. So this n square p square and this n square p square plus minus get cancel, and here we remain is minus np square plus np. So n and p get common, so np into 1 minus p, and 1 minus p means q. So np is our variance. Let's see the MGF. Our MGF for binomial distribution is mx of t is equals to q plus p e raised to t bracket raised to n. Let's see how to prove it. Mx of t is equals to summation e raised to tx p of capital X is equal to small x. This is basic definition of our MGF. MGF is moment generating function. So mx of t is equals to summation is as it is e raised to tx, p of x means our probability mass function, ncx p raised to x q raised to n minus x. So mx of t is equals to summation ncx, this e raised to tx, this e raised to tx we can take inside e raised to tx and p, both have index same, दोनों की पावर सेम है xx, तो इनको हम p e raised to t bracket raised to x ऐसा लिख सकते हैं. ओके, एंड q is as it is q raised to n minus x. So our mx of t is equals to q plus p raised to t bracket raised to n. Again this is binomial formula or binomial expansion which we earlier defined. So this is our MGF of binomial distribution. Mx of t is equals to q plus p e raised to t bracket raised to n. Very simple.